What's up, goblins, and welcome back to Oxygen Not Included! Today I want to take you on a journey through my own private colonies to show you some of my most favorite builds I built here, and I will start with some very common setups and then we will quickly go further to more advanced setups. So let's start with this nice and tiny bathroom over here. Let's go! The first bigger setup you will most probably build in your colony is a bathroom, and the bathroom is very powerful. It does not only give your duplicants a way to relieve themselves, stay happy and clean, but in fact it can even generate fresh water for your colony. So how does this work? For that we must have a look closer here on this build. So my build itself consists out of 6 showers, and underneath we have a small room with 3 sinks and then 3 toilets. The showers, however, are of course optional. So now if we have a look on our piping system, we can quickly see that we have a completely self-containing loop here with fresh water. So each of these buildings requires fresh water to function and outputs polluted water during their use. Now, how do we make this self-containing loop here? So the magic behind this is the lavatory itself. While the sink and the shower both require the same amount of water as they have in output, the lavatory actually has a higher output in polluted water than it has in fresh water as income. And that's how we are able to generate all of this fresh extra water here. And this is how it works. So we have our fresh water loop here, feeding all of our buildings with fresh water. If they then are getting used, we can see this over here with our lavatory. They will output this polluted water and feeding this inside our water sieve. This water sieve then will produce fresh water for us again, feeding our loop. And every time we have too much fresh water, and this is completely overfilling, this extra fresh water is then fed into our SPOM directly. And the SPOM is what I want to talk about next. So let's go there. Of course, we have to talk about the probably most used standard build in Oxygen Not Included, a SPOM. So what is a SPOM? SPOM stands for Self-Powered Oxygen Machine, and that's actually already the magic behind this. So a SPOM is a larger cluster of buildings which produces large amounts of oxygen while also producing so much hydrogen that you can actually just completely power this SPOM just with itself. And here is how this works. So we have our electrolyzer. This electrolyzer is getting fresh water as input and outputting a large quantity of oxygen and hydrogen gas. This hydrogen gas then, if we have a look here on the materials overlay, is kept up here, flowing into our first gas pump, and this gas pump then is delivering this hydrogen into our hydrogen generator. And this is also the specialty about this. Since it is self-powered, we do not need any further power from outside our grid. We have a very independent grid here, so no matter what happens to our main grid, this always stays intact, leading to a very good and constant supply of oxygen. So the oxygen itself then of course also is getting pumped out here with our gas pumps and then feed it into our main oxygen supply. And as I said, the SPOM itself produces so much hydrogen that we actually produce more hydrogen than we need to fuel our SPOM. And what I do with this extra energy here is that I simply collect this and then feed it into my hydrogen generator down here, which then also powers my colony. So that's why a SPOM is so extremely powerful. It produces oxygen for you, and it even produces more power because it produces so much hydrogen that it can power itself and also has some exhaust hydrogen left. And why you see here this special pattern. So usually you build only 1 or 2 maybe larger SPOMs for your colony. But I really like to have these brick-like smaller SPOMs because they are easy to set up. It only takes a short amount of time to set them up. And it's also very, very easy, as you can see here, to extend them if the need arises. Of course, this is also a little bit less efficient because you need more tiles, you need overall a little bit more material, but I really like this design, that's why I chose this. Okay, this was everything about my most standard designs, I'd say. Now I want to come over to a little bit more advanced design, so let's go. This setup is a little bit more advanced, and that's why I want to say a few things more about here and explain this a little further than all of these standard builds I showed before. So, what do we have here? This is a natural cooling systems running with Wheezewort. So, whenever you want to cool down liquids or gases, or whenever you want to have very fine temperature control, cooling down with Wheezewort is a very nice option. And also, this is a lot more energy efficient than using, for example, a thermo aqua tuner directly. So how does this work? Okay, we have, as you can see, Wheezewort inside a completely isolated room with insulated tiles. These Wheezeworts, of course, consume phosphorite every cycle. So what we have to do here is we need to ship in phosphorite. This phosphorite comes from my Draco farm, is then directly shipped in here, and all of this is then delivered with my auto sweeper directly into my Wheezewort, so we don't have to maintain this manually with our duplicants. This auto sweeper, however, is also connected to a thermosensor, because the problem with Wheezeworts is, as you can see here, they have a body temperature from 60 to minus 95 degrees Celsius, but in theory they can even cool down further and stiffen themselves if they do so. And that's why I have a thermosensor attached here. It says, okay, whenever we have temperatures below 20 degrees Celsius, please turn off this auto sweeper to not deliver any more phosphorite. And if that happens, our plants cannot stiffen themselves. And also we can spare just some of these juicy phosphorite blocks, of course. Okay, so, and of course, to cool down stuff, we have to pump in stuff. In this case, I use this here to pump in fresh water and pre-cool this fresh water for one of my SPOMs to cool down the SPOM. Okay, so, and here is how the cooling works. So right now we can see nothing's moving. And that's because I have a liquid shutoff connected to a liquid pipe thermosensor installed here. And whenever we reach a temperature below the given range here, 25 degrees Celsius, we can then use this to let some of this water pass. And that's also why I said this is very, very good for very fine temperature control. Also note that as atmosphere, we are using hydrogen gas here because hydrogen gas is the most efficient gas in terms of the heat capacity and heat conductivity. So if you want to use this the most efficient way, use hydrogen gas, at least 2,500 grams per tile. And now let's see how this goes once all of this is cooled down. Okay, we now almost reached the point at which this thermo sensor will activate our liquid shutoff here. Let's have a look how this goes. So now we reach 25 degrees Celsius and this liquid pipe thermosensor should turn green any moment. And now that it's green, we can let all of this nice and cold water passing through, and new water at what we have here around 90 degrees Celsius is coming in, filling this room, and now is getting cooled as well. Okay, of course, you cannot only do that with liquids, you can also do that with gases. For example, here we have some very hot or relatively hot natural gas coming in here, and I also cool down this natural gas to then deliver all of this natural gas into my kitchen. So these are two very nice ways to also cool down stuff without the need to invest a lot of power or to make a thermo aqua tuner setup here. And I think that's all I wanted to say about this build here. Let's now finally go over to the most advanced builds I have here for you today. The next monster setup that you can already see in the background here is my natural planted mushroom and waterweed farm, and this one is gigantic. So there is a big reason why I made this. You can also see that I have a very specific ratio in terms of mushrooms and waterweed here, and this is the exact ratio we need to produce mushroom quiche in our kitchen. And mushroom quiche is one of the most advanced food you can produce with your gas range here. Let's have a look at this. So the mushroom quiche is of superb quality and thus gives us 16 morale. It also comes in with 6,400 kilocalories, so this is pretty juicy stuff. But to produce mushroom quiche, we need fried mushroom, lettuce, and omelette. Okay, so let's have a look again on our natural farm here first. I will also show you how to produce this omelette. I used pips for this, by the way. We can already see the pip stables on the left side here. But let's talk first about this one. So, as you can see, we have a very classic natural planting pattern here of 3 times 3. So we have 3 times planted stuff and then 3 tiles, nothing planted over here. And this is the exact behavior you want to abuse with your wild natural planting pips. If you don't know anything about natural planting for pips, I highly recommend to watch a guide video about this, because this is very powerful, since we don't need any resources to grow these dusk caps and our water wheat now anymore. And of course, I also automated all of this. So as you can see here, we have some sweepies sweeping up all of this falling down stuff here, like seeds, or if our duplicants come over and harvest this, like our harvestable stuff, they then bring this to their sweepy dog, and my auto sweeper is then delivering all of this with a system inside our cooler. Yes, we did it. Where is it here? That we have over here. And here we have a deep freeze cooler sitting at around minus 200 degrees right now to cool down our food and deep freezing it. And so that's why we have so many calories, because with this deep freezer, food does completely stop any spoilage. So you can completely stop spoilage with the deep freezer, and that's why we have so many calories available here. Okay, so that's about my farm. Of course, we want to talk about how I power these, and I will power this, in this case, with coal generators. And of course, the coal generators are also fully automated with a smart battery. And I also have here a conveyor receptacle with fresh coal, which is then delivered with my auto sweeper. Also, I have another setup down here, a second coal generator setup, because apparently one wasn't enough to power all of this stuff here. It really went a little bit bigger than in the end than I actually planned when I made this. And on top of that, since we have so many buildings, we also need a method to cool this down. We could, in theory, cool this down with our natural cooling method that I just showed you before with our Wheezewort farm here. But in this case, I decided to make a thermo aqua tuner setup just because it's easier, and I have so much energy available in this colony that I don't really care about the energy. And so this is just filled with casual polluted water and then cooling down everything here. Look at this massive cooling loop. Okay, so this is how you grow naturally dust caps and water wheat inside your natural farm. But of course, for mushroom quiche, we also need omelets. And for omelets, we need eggs. First, we need to crack these eggs into raw egg, then cook this into omelets, and then throw this into our gas range to produce mushroom quiche. So how do we get a massive amount of eggs, but without killing our complete population? Well, that's pretty easy. You could either do this manually, if you want to assign here a certain number of eggs, for example. You say, okay, I want to have 20 eggs chopped down right now if you have 20 eggs laying around. Or you can automate this, of course. And to do that, we must have a look on our pip farms. So pips, very nice to farm. There are way more efficient ways to get omelette, by the way, not only by pips. You can get more omelette if you went for parkours, for example. But in this case, I decided for pips because I want to have more dirt for my colony, and dirt is something pigs excrete. And also, I really like the view of pips. They are just absolutely lovely. And how do I automate this now? Okay. So this is the system, and this is a little bit complicated. So whenever our pips drop their egg, this egg will go into our conveyor loader, from there on into our solid filter. And this solid filter now does either two things. The solid filter is directly connected with its output. We can see this over here. It's set to, where is it? Anyway, this is set to, here, filtered solid output, of course, pip X. Okay. And these pip eggs are directly transferred into my conveyor shutoff. But I also have a shortcut in case this conveyor shutoff turns down. So we cannot see this here, but if this goes off, the pip egg will not flow this direction around here, but rather directly into my bridge here, into my conveyor bridge. And so whenever this conveyor shutoff is turned off, it will flow inside this small room over here. This is a room that's not accessible for any duplicant. That's why this is so important. It's only accessible from our auto sweeper, as we can see over here. So all pip eggs are getting dropped then over here that we need. And this is set here, automated with, where do we have it? Wait, give me the automation overview here, with a critter sensor. So whenever we have above, here, send green signal, whenever we have above 4 eggs lying around in this small room here, whenever we have more than 4 eggs, this conveyor shutoff turns on and let eggs pass through here over this bridge, another bridge here. And then these eggs are immediately delivered into our kitchen for the egg cracker. That's why I have this here on just forever. And if our conveyor shutoff turns off, as I said, they go inside this room here, and we always have a steady supply of fresh eggs lying around here with which we can really ensure that we're not running out of pips over time, right? So that our duplicants do not crack every egg open they can find here. Also, another thing I had to automate here to make this is I had to automate these doors. So whenever a critter egg, no matter how many, just one critter egg is already enough, is getting dropped inside this room, this door here completely closes. And this ensures that duplicants do not run inside this room, override the auto sweeper and just grab all the eggs and then run out to the kitchen again. If they have nothing to do, they really do that. They just come in here, the auto sweeper does nothing, and they just grab this egg and then run out here. So be sure you have also something to enclose this room. And then exactly, whenever this egg is then carried out, of course, this is turned off and we can then open the door again for everyone to access this. Okay, so this is my method to create mushroom quiche with a natural plant farm and also, of course, with an attached pip farm here. So that, I think, is already pretty advanced, and I hope you learned something from this here. And I'd say now it's time to finally go to my most advanced setup I have here for you today. Let's go. The most complex setup I want to talk about here today is also absolutely my favorite, a Volcanoe water purification system. So how does this work? As we can see over here, we have a volcano sitting here. This is the source that is delivering us the heat we need to evaporate all of this water fast. And we can see that we have this volcano here geotuned for 4 times, and it's spitting out magma at 2300 degrees Celsius. So this is definitely a very, very nice source for heat. Also, because this volcano is so hot, we have to make sure that we only use very heat resistant materials if we build this, for example, obsidian, steel, or diamond. Okay, and I want to start with this single room here. This is directly attached to our volcano. We can see we have a magma blade here. This magma blade is then hitting this window tile over here. And whenever we need some heat, we will just close this steel door. I'm pretty sure you already have seen that. And whenever we close this steel door, we can transfer heat between this window tile and then the other window tile on the other side as well to deliver heat inside our steam room. And in case we have some tiles here clonking up, I also inserted a robo miner. And of course, since this magma is cooling down a lot, we also have some igneous rock forming from time to time. And that's what I want to sweep out with my auto sweeper and my conveyor loader. And so that's the reason why this Volcanoe Tamer is so nice, because it produces so many resources for us. It produces, of course, power from our steam turbines, and it produces a lot of power. One very well-tamed volcano is already enough to power a small colony alone. Then, of course, we have this igneous rock that we here produce this is also very cool because igneous rock is a very common construction material, so we will also never run out of construction materials. The second thing we produce, of course, since this is a water purification system, we also produce fresh water with this. And this is how it works. So we have some either, in this case, brine or polluted water flowing inside, right inside our Volcanoe Tamer system here, our steam room, and then immediately evaporating this. And as you can see, brine also brings us some more salt within this system, and polluted water can produce dirt. So as byproduct, we even have salt and dirt sitting around here as well. And so this fresh water then is captured, not directly by a pump. No, that would be silly. I am capturing this with my steam turbines, and my steam turbines immediately cool down this steam, no matter how hot this is, to 95 degrees Celsius. And whenever I need fresh water, I can turn on my liquid shutoff here. Of course, all of this is also automated. This is something I want to tell you in a moment. So be patient and follow me here. And this liquid shutoff then is delivering all of this water inside my main line for my main SPOM. Okay, so how does all of this stuff work? Let's have a look on the automation system. And you can already see this is a little bit more complex. So first we have a thermosensor which is controlling our steel door. So this thermosensor is telling the steel door to always close if we fall below 215 degrees Celsius, so that we make sure that we always have a good amount of heat stored inside this room. Otherwise, it will open the door, and since the door is open, then there will form a vacuum, and a vacuum in oxygen not included means that there is no heat transfer whatsoever between these two window tiles. This is how we can prevent to completely overheat this room, because if we let this mechanized airlock here just in place and just completely heat up our room all the time, this will overheat this room extremely quickly, especially our machinery here. We have a thermal aqua tuner here, auto sweeper to sweep out the salt and the dirt we get from our polluted water, right? And so we don't want to overheat that. That's why we are only heating this to 215 degrees Celsius. So this is very important and the most crucial part of your Volcanoe Tamer, of course. So let's have a look on the next thing. This is also a very easy thing. We have here the liquid pipe thermosensor. This is explained pretty fast. We have a cooling system here with supercoolant, and this tells our thermal aqua tuner to cool down this supercoolant or not, depending on the heat stored in our supercoolant. So depending on the temperature of our supercoolant. Okay, now let's come over to the more complex things. First, how do we run our steam turbines? Our steam turbines are run either by the smart battery, because of course I don't want to let's have a look on this. I don't want to waste all of this power. Or it is running with another thermosensor over here, which is set to 245 degrees Celsius. So whenever there's any problem, for example, this door is not opening correctly, I'm immediately telling my steam turbines to turn on to prevent overheating, at least for a little bit of time. So that I also have some overheating mechanism inserted here. Because if we have a look on our auto sweeper, the auto sweeper already starts to overheat at 275 degrees Celsius, and of course we don't want it to break, because once your Volcanoe Tamer steam room is closed, it'll better stay closed for really forever. Otherwise, this will cause some problems if we have to go in here and repair this auto sweeper. So it's very, very important that you have some method to override your smart battery to prevent overheating this room. Okay. Now we know when the steam turbines are going on, but we still have to figure out how do we turn on our liquid shutoff. So the liquid shutoff is turned on in two ways. It is either turning on if this thermosensor, because we have a NOT gate here, falls below 245 degrees Celsius. Remember, we don't want to sweep out water here if we need all of this water inside our room to cool it, right? So we have to make sure that every time we go above this given temperature here, that this immediately shuts down our liquid shutoff. And so this is also connected with another sensor inside our AND gate. And this sensor is a pressure sensor. So this measures the pressure of our steam inside this room. And whenever this drops below a certain threshold, it will also turn off our liquid shutoff, because I always want to maintain at least, what did I say here, around 14,000 grams or 14 kilos per tile of steam inside this room. This is very important because whenever we deliver water inside here, we want to make sure that we immediately completely evaporate this. And especially important is this if we use polluted water, because polluted water, if you have too low pressure inside your room, will inevitably also output some polluted oxygen. And this polluted oxygen will pile up at the bottom, not at the bottom, at the top of your room, and completely blocking your steam turbines from working. So you always want to make sure that it's A, hot enough in your room, and B, that you of course also have enough pressure inside here to prevent your polluted water from gassing off into polluted oxygen. So this is how we activate then with this AND gate our liquid shutoff, either if the temperature is low enough and of course also if we have enough pressure inside here. Now we need to find out how do we deliver fresh water inside here, because of course if we just let this run and let fresh water drop inside and inside and inside and further and further and further, it will at some point maybe even be enough to completely cool down this room here to a point where we start to see just casual water forming. And of course we don't want to do that, because then with casual water, of course, we're not able to evaporate this immediately, and we get again more polluted oxygen inside this room. And so we need a method to tell our second liquid shutoff, which here comes in with our fresh and nice brine or polluted water. We need to tell it when to turn on and when to deliver fresh water here. And there are two things that are very crucial. First, the thermosensor. So this liquid shutoff will only deliver new and fresh water if this room is hotter than 150 degrees Celsius. And this makes sure that our water immediately evaporates and does not form any normal water which can then off-gas. And also, as we already have over here, I also want to have another atmos sensor here, which tells this liquid shutoff, okay, whenever we have below 20,000 grams of steam inside this room, please deliver fresh water. In theory, this is not very well needed, but I don't want to flood this steam room here with hundreds of kilograms of steam. And so I decided to also insert this atmos sensor here. And whenever these two conditions are met, they will turn on this AND gate, and this AND gate will then also ultimately turn on my liquid shutoff. Whew, okay, that was a lot of automation, but now we know how this automation system here works. But of course, there's also a second part I want to at least talk about a little bit. So this is also a very common thing you will see with my Volcanoe Tamers that I also have in my YouTube runs. And this is a second tamer, which then also takes care of the igneous rock, because remember at the beginning I said that sometimes we have igneous rock forming over here. And of course this igneous rock is pretty hot. So we can see that we have igneous rock lying around here at 1300 degrees Celsius. And of course we don't want to just dump all of this very hot material right into our base. This would hyperheat our base and cause a lot of problems and a lot of buildings to break and melt. And so what we have to do here is to cool this down first. And that's why we have this cooling here, this cooling system with 4 steam turbines again, delivering us a massive amount of power on top of the already existing power delivering Volcanoe Tamer here. They are also completely connected to a smart battery system here. And the thing behind this here is very simple. We simply have a just casual steam room over here, which then transfers all of this heat from our igneous rock to our steam, and steam is then captured by our steam turbines and immediately pumped back into our steam room to cool down our igneous rock. And all of this is then also further cooled with a cooling loop over here on top of this metal tile to cool it down even further. Because of course we are limited in the way we can cool this down. So for example, I have this set to 150 degree, which is still pretty hot. And then we get the rest of this energy by putting this on our metal tile here. We could also go lower here. So in theory, I think steam turbines are working until 125 degrees Celsius. So we could also set this to 126 degrees Celsius, which would recover a little bit more. Just recover a little bit more power from this and also make it a little bit easier for your cooling loop to work here. But in this case, I have this set to 150 degree because I want to have a higher output of igneous rock. Okay, I think that's everything I wanted to say here about this setup for today. Please let me know in the comments if you were able to follow my setups and what you think about my personal setups I made here in my private runs. And I'd say that's it for today, and I'll see you next time. Bye bye.